So, ang topic namin is regarding sa different types of instrumentation. Pero, hindi lang din matatapos yun. At dinagdagan namin siya ng different measurement techniques. So, ito siya. Una, ano nga ba yung instrumentation? So, instrumentation is a collective term for measuring instruments used for indicating, measuring, and recording quantities. And it has its origin in the art of science of scientific instrument making. So, dun pala nagsimula yung instrumentation. At kadalasang ginagamit ang instrumentation sa industrial control system, katulad ng manufacturing industry, vehicles and transportation. So, pwede rin namang mahanap yung instrumentation sa mga simpleng lugar lang, halimbawa sa mga household or sa mga bahay natin. Ang halimbawa nito yung smoke detector, at para naman sa mga lugar na may malalamig na klima, ay meron tayong tinatawag na thermostat. So, yun. Natapos na natin i-discuss kung ano nga ba yung instrumentation. So, ito na yung magiging outline nung reporting namin. So, ito nga. So, para sa outline, ang una natin i-discuss is yung temperature measurement na merong dalawang classification, which is yung thermocouples at resistance thermometers. Tapos susundan to ng pressure measurement, flow measurement, and level measurement na i-discuss ng iba ko pang kagrupo. So, yun na nga. Tapos na yung part ko ng reporting. At ipapasok ko na sa susunod na reporter.
So I'm gonna report about thermocouples and its principles. So basically, this is its fundamentals. Let me read to you. Thermocouples are two wires of dissimilar metals joined at both ends display a continuous current if one end is heated. If the circuit is broken, a voltage is established, which is a function of the junction, temperature, and the composition of the metals. So, as you can see in the drawing, there are two types of metals, and there is a candle or a heat source of heat that would distinguish the two dissimilar metals. And yeah, and it says here that because of the temperature measurements via thermocouples are common and simple, many errors in their use and interpretation are also common. To avoid these, it is helpful to understand the physical principles behind the signal generated by the thermocouple. So basically, that's the role of thermocouples. And these are the important terminologies or fundamentals in terms of thermocouples. So there's electric current, there's thermal current, and these are the equations that are commonly used for thermocouples. That equation, this equation, and these are the equivalent meanings of every symbol, and basically that's all about the fundamentals of thermocouples.
A few moments later.
Consider a circuit connected to a potentiometer wherein the two leads have the same composition, the same temperature, and same chemical potential. By combining the two equations, we have note that an open current voltage areas from regions where dt over dl is not equal to 0. Voltage difference from point 0 to point 5 open circuit voltages arises from region of dt over dl is not equal to 0. Note that although region A and B are known, LT in the joints is unknown. Joints must be in regions where dt over dl is equal to 0. then is found in the tables. Yay, yay, yay. It represents the difference in the voltage generated by materials A and B, both spanning the temperature 0 degrees Celsius and T2.
Hello po, Karian nga po pala. Naisip na ba natin kung paano gumagana yung mga electric stove? Kung paano nito nabibigay yung specific na temperature na gusto natin? I-adjust pa natin depende sa kung gaano kainit natin gusto. Well, ang mga electric stove kasi is gumagamit ng thermocouples. So, ano ba yung thermocouples at paano siya gumagana?
A few inches later.
Ang thermocouple gawain sa dalawang wire na magkaibang metal. At sa dulo nito, naka-weld siya na tinatawag nating junction. Pag nagkaroon ng pagbabago sa temperature ng junction, nagkakaroon ng voltage. At yung voltage na yun, yung ginagamit natin para makakuha yung temperature. So dahil yung temperature reading natin nakabase sa voltage, meron tayong tinatawag na compensation para makakompensate natin yung inaccuracies at yung pagkukulang ng reading para maging accurate. So, meron tayong dalawang configuration. Una yung software configuration sa hardware configuration. Yung software configuration, doon yung unang reading natin is yung voltage reference. Tapos dahil sa voltage reference na yun, makukuha natin or makakompute natin yung VT. Pag compute natin yung VT, makukuha natin yung value ng temperature natin sa reference table. Tapos yung reference table naman, nakabase yan kung anong klase ng thermocouple yung ginamit natin. Yung hardware compensation naman, nakabase na ngayon, nasa settings na ng hardware yung pag-read ng thermocouple. So, ibabypass na niya or ika-cancel na niya yung VREF at automatically, ang may-read na niya is yung VT. So, from there, gagamitin natin yung reference table para makuha yung temperature.
Ngayon, magpapakita natin kung paano mag-solve ng isang thermocouple problem. A type E thermocouple is used to measure T is equal to 80 Kelvin with temperature reference 40 degrees Celsius or 313 Kelvin. For the first question, what voltage is measured at the meter? Solving the measured voltage, convert muna natin yung 80 Kelvin to degrees Celsius, which will be negative 193 degrees Celsius. The formula is V measured is equal to temperature voltage minus the reference voltage. Then, it will be negative 8.643 minus 2.420 na magiging negative 11.063 volts. The next question, what is the reference voltage? So makikita natin sa chart nandun yung yung certain voltage corresponding to the temperature. Yung natin is 40 degrees Celsius at ang makukuha natin is 2.420 volts. Yun na yung sagot. For the next question, if the voltage resolution is 0.01 millivolts, what is the temperature resolution? So then we have 80 Kelvin and dV over dt is equal to 26.8 voltage per Kelvin. With dV is equal to 10 volts, therefore the derivative of temperature is equal to 0.37 Kelvin.
I-discuss namin yung about thermopiles, which is a set of thermocouples that is connected in series and parallel connections. So to increase signal, kailangan tayo, parallel connection of n pairs, which produces n times the EMF and reduces temperature error by 1 over square root of n. To determine a spatially average temperature, meron tayo dito makikitang V1, V2, and V3. So, ayun, we have equations V1 is equal to T1 plus T, V2 is equal to T1 plus T times T1, then V3 is equal to T1 plus T plus blank, times T1. So therefore, makuha tayo ng V total na 3 times the temperature. Ganun lang po.
Hello there mga friends. Kahit tayo Monsanto po, nagulat tungkol sa aking report, cryogenic thermocouple. Dito. So, cryogenic thermocouple so ay commonly used for cryogenic temperatures. May tatlo pa tayong type dito. Type E, Type K, at Type T. Ngayon, bawat isa naman po may iba't ibang thermal conductivity. Isa, 4.1, 50 seconds. Tapos yung isa, 8.5. So, tapos po ito po important note sa paggamit ng thermocouple. Tandaan lang po natin tomato, 40 seconds. Tapos, hindi mga seconds. Yeah. Tapos sa mga thermometers po, tatandaan na ang kailangan pag-consider mga temperature range, type of signal, mounting package, magnetic sensitivity, long-term stability, calibration, saka yung mga cost po. So, may naman po mga report dyan, sa kali po. Check na lang po yung ibang notes. So, ako ito lang po. So, yun po yung report ko. Tama.
Good day. So after considering many things about thermometers, so ngayon naman i-discuss ko yung about sa iba't ibang klaseng type ng thermometers. So ito yung una, diode type thermometers, which are semiconductors. So ang other names nito, silicon gas or tinatawag na GAIAS. GAIAS. So ang characteristics nitong type na to ng thermometer, temperature dependent forward bias voltage, small but fast response, then constant current source, specifically 10 amperes, and very field dependent, and lastly moderate sensitivity over large T range. So next is yung tinatawag na PTC resistors. Ito ay metal. So PTC, it means positive temperature coefficient. So ang other names niya ay platinum and rhodium iron. So ito ay very stable, large size but slow response, sensitive to magnetic fields, fairly good sensitivity, and strain sensitivity. So next naman ang type ng thermometer ay ang NTC resistors. Katulad siya ng diode type, which are semiconductors. So other names niya ay CGR o carbon glass resistor, GR, CR on ruthenium oxide, or Cernox. So NTC stands for negative temperature coefficient. So ito siguro yung kabaliktaran ng PTC, which is positive temperature coefficient. So ang characteristics nito, high sensitivity over limited temperature range. So yun yung CGR, GR, CR, yun yung mga klase nun, other names. So negligible field dependence, large field dependence. So meron dun sa mga sinabi ko, yung CGR, Cernox, ruthenium oxide, ito yung negligible field dependence. Then yung GR naman, yun yung large field dependence. So ito, strain sensitive, encapsulated thermal sensing through the leads, and it has moderate response. So last yung capacitors. Ito, insensitive to sa magnetic field, and sensing circuit requires care and attention. So yun yung mga type ng thermometer. So bawat other names na nasabi ko, usually may iba't iba yun na characteristics. Pero yung mga type na yun, nakapaloob sila dun sa mga nasabi ko, which are diodes, PTC resistors, NTC resistors, yun yung huli yung capacitor nga. So after masabi yung mga iba't ibang types, ito naman, may example kung ano-anong klaseng thermometers yung gagawin sa different situations. So ito, paano kung tayo ay winding of Tevatron magnet? So anong klaseng thermometer yung dapat natin gamitin? So dapat Ang suggestion, Cernox, CGR, or ROX. So, bakit? So, katulad nga sinabi ko kanina, katulad dun sa PTC resistors, ang nakalagay doon, sensitive to magnetic field. So, from the word itself, sensitive nga, 'di ba, sa magnetic field. So, if we're going to wind Tevatron magnet, so dapat hindi tayo gagamit ng PTC resistors. Kaya ang mga sinuggest dito, mga nakapaloob sa NTC resistors. So, next, fluids experiment in helium. So, ganun din. Ito naman ang suggestions dito, CGR, CGR, and Cernox thermometers. Next, characterize performance of liquid hydrogen liquefier. So, ang mga suggestion naman na gamitin dito, GR na thermometer, PD na thermometer, rhodium iron thermometer, and Cernox thermometer. So, it's either dun sa PTC or sa NTC, dun niya kinuha yung mga possible na gamitin sa activity na to. So, ito naman, cool down study of an 80K cryo cooler. So, ang suggestion is platinum, TC, silicon diode, and Cernox. Yun lang. Thank you.
And thermometers. Factors contributing to uncertainty ay una, sensor sensitivity. Pangalawa, voltmeter uncertainty. Pangatlo, current source uncertainty. Pang-apat, calibration uncertainty. Panglima, thermal noise na madalas naman na negligible na. And pang-anim ay yung electromagnetic noise. At combined total uncertainty is yung summation ng mga factors na nabanggit ko nung una, and ito yung formula niya. And next ay yung factors contributing to error. Ayan yung representation niya, the graphs on the right corner. And yun lang. Maraming salamat. Signing off.
So hello, I'm Ryan Saragosa, and this is my report about factors and contributing to errors in thermometers. This is for the engineering management subject with Professor Alexis Lawson. So here you can see the error factors in thermometers. So one of the error factors is parasitic heat leak. So as you can see, there is an illustration here and an example. Then lead resistance. So here there's a problem regarding the sensors, and there's a solution, for wire connection solution. Yes. Then another factor is thermal EMF. So there is a problem, and the Seebeck coefficient of different materials in regions of T produces a thermal EMF even when no current is flowing. So the solution is reversing the polarity or multiple current levels.
So ayun, yung i-discuss ko muna is yung mga do's and don'ts sa thermometers. Yung una is yung pagsusukat sa temperature ng isang surface. Kailangan ay 5 to 10 centimeters lang dapat yung agwat niya dun sa lead, sa surface. Next is yung paggamit ng shielded or yung twisted na LEDs kapag sa susukatin mong surface ay involved ay may electric. So, para ma-minimize yung electromagnetic noise nun. So, next is yung pag-minimize ng conduction ng heat. Kailangan kang gumamit ng thermometer na may LED na may mababang thermal conductivity. Tapos yung dimensions ng thermometer, mahaba siya tapos maliit lang yung diameter. Tapos yung lastly is yung sumunod lang sa recommended na excitation levels para maiwasan yung self-heating ng thermometer. Tapos punta naman tayo sa mga pressure devices, yung mga instrumentations para sa pressure. So yung una is yung Pfizer transducers. Yung transducers, isa siyang device na nagme-measure ng physical quantity na kino-convert niya into electromagnetic signals. Sa Pfizer transducers, ang mini-measure niya is yung mechanical strain ng isang mechanical component or kahit na naman. Ang Pfizer transducers ay may resistance bridge na may 4 na active arm strain gauge. Ang examples ng Pfizer transducers ay NDEVCO 8510B na nagkakahalaga ng 1K dollars, mga 50,000 sa Pinas. Tapos next is yung pressure capillary tube. Madali lang to, ano siya, pressure capillary tube. Maliit lang siya na tube na nagme-measure ng pressure between sa dalawang fluid. So ang ano lang naman dito, ang recommendation dito ay pag-extend niya kung ang pressure capillary tube ay isa-submit mo siya sa under cold pressure. So kailangan mahaba, cold to room temperature. And then leak tight dapat yung pressure capillary tube mo. So yun lang naman. Thank you.
Variable reluctance transducers. Magnetically permeable stainless steel diaphragm clamp between inductive pickup coils. Diaphragm displacement changes induction of both coils. AC bridge converts inductive change to proportional DC output voltage. All pressure transducer sends pressure from the outside mechanically, and it will produce an electric signal in response to these changes. When it comes to the variable reluctance pressure transducer, a sensing diaphragm changes position with pressure inductively changing the impedance of two sensing coils. This change produces an electric signal. Next, we'll show you an example of a variable reluctance transducers. That's all. Thank you for watching.
I'm Erlen JB Dario, and I'll report about two-phase flow measurement. Yung two-phase flow measurement, in-estimate nito yung liquid and mass flow rate natin. Measurement of flow quality in a two-phase mixture, liquid and vapor, is difficult. Bali, yung velocity ng vapor natin dito at liquid, pwedeng magkaiba. And flow regime is not known. Yung flow regime natin, bali yung liquid and gas, nape-pair sang mag-flow together in one pipe. Measurement of void fraction is more straightforward. Capacitive meter based on different dielectric constant, coaxial capacitor, and optical techniques. Total mass flow rate can be determined in some part of the circuit where the fluid is single phase using a conventional flow meter. Ang conventional flow meter naman natin, bali isa siyang device kung saan minimeasure niya ito yung individual phase ng mass flow rate natin. Next is liquid level measurement techniques. Continuous level measurement. Bali yung continuous level measurement, minimeasure naman nito yung uninterrupted basis. Minimeasure natin liquid level natin in an uninterrupted basis. Bali, ang example natin is superconducting wire level device, capacitive level measuring system, transmission line system, ultrasonic level measurement, hydrostatic or head level measurement, and discrete level measurement naman natin. Ang example naman ito is liquid vapor detectors. Next is acoustic dipstick method. And last one is mass measurement or gauging. Bali, ang mass measurement, syempre, measure natin yung mass flow rate natin.
Yun. So, yung topic na ay di-discuss ay liquid level measurement techniques. So, yun napunta sa akin ay superconducting wire level meters. So, ang sabi dito ay developed by Everson 1970 but now a commercial product. Heater drives the normal zone of SC wire to the liquid interface where it stops due to improved heat transfer. Units are most often calibrated in LHE at 4.2 Kelvin. Variable performance in HE due to improved heat transfer. Some SC level meters based on HTS materials have been developed. So, yung topic ay liquid level measurement technique. So term pa lang na superconducting wire level. So, ang pagkaintindi ay mabilis niya monitor yung level ng water na mini-measure. So, next ay capacitive level gauges. Ito yung image. Most are custom. Some are valuable as prototype commercial units, particularly for high dielectric constant fluid. So, feeling ko, mas madalas siyang ginagamit sa mga gawa siya sa electric. Mas common siyang, hindi siya common ginagamit. So, yung last, yung differential pressure head gauge. Ang requirements is pressure gauge must be located in cycrostat. Yan. So, yun lang yung tatlong topic na start ko. Okay.
Yun na nga guys, kakatapos lang nila mag-explain sa mga ilang types ng instrumentation. Ito nga sa akin, may naka-assign din sa akin para explain. Sana ma-explain ko siya na maayos at na yung sinain ko.
A few moments later.
Ito na nga guys, ito yung una kong i-explain. Transition level technique. Ayan, kung mapapansin nyo, ang system na to ay developed by Lindstorm noong 1970. Based on reflected signal in a coastal line partially filled with liquid. Ito, kung makikita yung drawing, oh. Ayan yung liquid level. Ito yung measuring cable niya. Ito yung delay, yung pulse generator, matching impedance, saka yung comparator. Itong design na daw na to, mas madali siya sa capacitor. Tsaka kung mapapansin nyo, small heat deposition and fast response make the device attractive. Attractive daw yan, guys. Yun na nga, yun yung una. Ang lino naman pagka-explain ko, di ba? Move on na nga tayong susunod. Pangalawa guys, yung ultrasonic level measurement. Simple lang to guys. Ginagamit niya yung sonic waves para ma-detect yung level ng liquid. Ito. Ayan, ito yung level. Halimbawa, ayan yung level ng liquid. Ito yung mga basic parts niya. Yung transducer, transmit pulse, echo pulse, transmitter, receiver and computer, timing information, and readout control. Yung huli guys, ito yung discrete level measurement technique. Isa siyang liquid vapor detection. Ito yung types of devices niya, yung superconducting thin films, hot wire or film, and semiconductors. Operating current must be sufficient to self-heat the sensor in vapor but not in liquid. Sensor must be small to minimize heat generation in liquid. Kung makikita nyo, ito yung mga parts niya. Ito yung naka-spot weld siya. Ito yung glass bead and platinum leads. Yun na nga guys, yun yung mga na-assign sa akin na i-explain ko. Sana naintindihan nyo kahit papano. Bye guys!
Ako nga po pala si Van Damon at magre-report po ako ng dipstick level measurement. Dito po pinapakita yung picture ng dipstick level measurement. Acoustic oscillation changes frequency and amplitude when capillary leaves liquid. And the second slide is heat pulse mass gauging, measurement of helium-2 volume by heat pulse technique. Ang equation po niya ay mass equals to Q over H. This technique is used extensively for space-based helium-2 cryostats but also pressurized helium-2 systems for superconducting magnets. So, ayan po yung elapsed time from start of pulse. Siya po ay based sa seconds. And the last page is the summary of level measurement techniques. So, andito po yung mga level of measurement of techniques. Thank you po.